once I talk about them, you're going to be like, oh, I know that. That's
No.
okay, so all right, a postulate or an axiom is a statement. Okay, a statement that is accepted as true. Okay, so you don't need to prove it to be true. It's already accepted as true. So most of your other theorems, so some of those theorems that we talked about last week, such as the midpoint theorem, those have to have a formal proof in order to use them. Okay? With your postulates and axioms, you don't need to prove them true. They're already taken as true. So postulates describe fundamental relationships in geometry. Okay, so basic ideas about points, lines, and planes are accepted without proof. Yes. Okay, so
Shut up, Kenzie.
Kenzie, put your phone away and take notes, please.
I am taking notes.
All right, put your phone away then. Okay, so these postulates that we're going over today are about points, lines, and planes. Okay, these are accepted without proof. They are the building blocks of geometry. The following below are your postulates for points, lines, and planes. So the first one is 2.1. So through any 2 points, there's exactly one line. Okay, so if you're given 2 points, okay, so if you're given 2 points, there will be exactly one line. Okay, so you get exactly one line if you're given those 2 points. Okay, so line N is the only line through points P and R. P and R are your 2 points. Line N is that line drawn through them. 2, 2, through any 3 non-collinear points, there is exactly one plane. Okay, so if you're given 3 non-collinear points, what does non-collinear mean?
Not on the same line.
Not on the same line. That will result in one plane. Okay, so your 3 non-collinear points here are A, B, and C. And plane K is that plane drawn through to make those 3 non-collinear points lie in that plane. Okay, 2, 3, a line contains at least 2 points. Okay, so if you're given a line, okay, that line has to contain at least 2 points. Okay, so line N contains 3, but it only needs 2. So points P and Q and R all lie on that line. So a line has to have more than 1 point. 2, 4, a plane contains at least 3 non-collinear points. So if you're given a plane, okay, it must have 3 non-collinear points. So plane K is here. It has 4 points. 3 of them have to be non-collinear, so L, B, and E. Okay? 2, 5, if 2 points lie in a plane, then the entire line containing those points lies in that plane. Okay, so if you're given 2 points in a plane, okay, so those 2 points lie in that plane. Okay, they have to be on that same plane. Okay, then you have a line in that plane. Or in the plane. Okay, so points A and B were in plane K. So points A and B in plane K. That means there's a line that can be drawn between or through those 2 points, and that line also lies in that plane. Okay, so that line has to also lie in that plane. Okay, next is 2-6. So if 2 lines intersect, then their intersection is exactly 1 point. Okay, so this one, if you're given 2 lines, okay, there is 1 intersection point. Now, sometimes you could have 2 lines that never intersect. What are those called? Parallel. Okay, so this one, if you have 2 lines and it does say they intersect, they only intersect in 1 point. They will not intersect in 2 or 3 or 4. Okay, just 1. 2.7, if 2 planes intersect, then their intersection is a line. Okay, so this one, if you're given 2 planes, then you'll have them intersect the T. Okay, so you'll have them intersect in a line. So if I have plane F here and plane G here, okay, their intersection is line W. 2 planes do not intersect in a point. Okay? You cannot have 2 planes intersecting in 1 point. 2 planes will always intersect in a line unless those 2 planes are parallel, in which case they won't intersect. Okay, I bought new ones. I didn't have any time this morning to put them up.
You bought new what?
Owls.
You bought new owls?
Yeah.
What about right now?
So like,
No.
we're gonna
I
do
didn't write the name.
tomorrow.
Yes.
You can do it when we have time to do our homework.
All right. On the back.
Wait, are you here to test back today?
No.
We don't even get to look at them.
So on the back, what we want to do is, given these statements, we want to state which postulate from the front it's talking about. Okay, so you can write 2.1, 2.7, whichever. So in number 1, we have planes P and Q intersect in line R. Okay, so here you can see plane P, plane Q. The line of intersection is line R. So if I flip to the front, I have 2 planes that intersect in a line.
Oh, 2.7.
2.7. I have 2 planes that intersect in a line. So number 1 would be 2.7. Number 2, lines R and N intersect at point D. So I have 2 lines that intersect at 1 point. 2.6.
Is the next one 2.5?
No. Number 3, line N contains points C, D, and E. So a line contains points. 2.3. Number 4, plane P contains points A, F, and D. So a plane contains points. No. Plane P is right here.
Oh,
It is 2.4.
yeah. You know.
The next one, number 5, line N lies in plane Q. Line N lies, it is 2.5. Number 6, line R is the only line through points A and D. 2.1.
Yeah.
It is 2.1. Okay, so you have those 2 points, and there's only that one line drawn through those 2 points. That's 2.1. Okay, next section here. If I have this statement, I have segment AC. This symbol means parallel. Okay, so segment AC is parallel to segment DE. So that's talking about this picture here. Okay, so AC parallel to DE. Okay, again, we want to state the postulate that makes this true. So the ones from the front. So number 7, exactly one plane contains F, B, and E.
2.2.
2.2. Okay, 2.2, you have 3 non-collinear points. They make one plane. Number 8, line BE.
2.5.
That's this one. Lies in plane Q. It is 2.5, you are right. Okay, 2.5, you have 2 points that line that plane, so there's a line drawn through those 2 points.
Never.
All right,
What's the point of knowing this?
what do you mean? The postulates?
Why do we have to know
Kenzie, stop.
It's logical thinking.
this? Logical thinking.
Mm-hmm.
So when I
Something.
need like a job, I can
You're gonna get a job.
All right, so next section, what you want to do is determine whether each statement is always true, sometimes true, or never true. I want you guys to do these ones in your groups.
First one?
Now, if you can think of counterexamples, then it's not going to be always true. Okay? You can write S for sometimes, A for always, and N for never.
You never used pencil. You even say that.
Okay? So talk about these in your groups. If you need to draw a picture, draw a picture. Okay?
No, you can't do that. There you go. Oh my god, I'm crazy. Beef jerky.
It's not because you need to have more.
It's not really like perfect. No, perfect. I like cheddar cheese. You don't like that? It's so good. I could eat a whole bag. That's cheese. It's tense sometimes. It's always, oh my goodness. Sometimes. Because if they're parallel, they don't intersect.
Good job.
Points H are contained in plane and GH perpendicular. That sometimes. Wait, what does perpendicular? Plane R and S intersect and point T. I'm using pen. I can't erase it, so.
We're just gonna
Yeah, why?
I don't know, like, there's no picture to look at.
But they're not.
But that's a lot of work.
Non-covalent.
They don't know all these
Bring it, watch it, so we all this.
Oh my God.
So it's always. Right? Okay. If points were A, B, and C are.
Hey, wait.
Alright, what else are all?
Yeah, so just. Oh.
Okay, now, okay.
It's 13.
No.
Is it never? So number 14, that's all. Math.
Yeah, we're so great.
Hold up. Let me get it started.
I actually.
All right, so what? What picture? What are you talking about? All right, so looking at number 9, a line contains exactly 1 point. How many points need to be in a line?
Probably two.
2. So this one is never. Number 10, non-collinear points R, S, and T are contained in exactly 1 plane. Okay, so you have 3 non-collinear points. They make up 1 plane. That's one of your postulates on the front. This is always.
Does it have to be 3?
Yes.
Why?
It can be more than 3. It can't be 2 though. It has to be 3 or more.
Why can't it be 2?
Because that makes a line, not plane.
It doesn't have to.
Number 11, any 2 lines L and M intersect. It is sometimes. It is sometimes because those 2 lines could be parallel and they will never intersect. Number 12, if points G and H are contained in plane M, then segment GH is perpendicular to plane M. So if you have 2 points, G and H, right?
Yes.
They're in this plane
Mm-hmm.
M, right?
Yes.
That segment created, will that ever be perpendicular to that plane? No. This is never. Okay, that segment will lie in that plane. It will not be perpendicular to that plane.
What is perpendicular?
Makes a 90-degree angle.
Connor didn't know.
I never wrote it down.
Wait, what? Shut up, kids.
Oh, that's exactly what you told me.
All right, 13. Planes R and S intersect in point T. 2 planes have to intersect in a line. They can never intersect in 1 point.
Oh, never.
So this is never.
The next one's always.
Shut up. Jeez.
If points A, B, and C are non-collinear, okay, so A, B, C, they're non-collinear, then segment AB, segment BC, and segment CA are contained in exactly 1 plane, okay? They all lie in this plane. They were on that plane to begin with, so this is always. questions on sometimes, always, or never. Okay, so what your quiz is on Wednesday, you do have a review tomorrow. It's really short. The quiz is really short.
Like how many questions?
Like really short.
6.
Like
Is the review sheet?
you
longer
have,
than the quiz?
yes, it'll be about the same. It'll be like about the same amount of questions. So on your